Okay, kid, let's just kind of a quick overview on couple of types of bodies of water that we look at it in limnology. Hopefully you got somewhere decent to go on the Great Lakes. I'm telling you, there's some really fantastic places to visit, and it'd be interesting to check those out and see what you guys came up with. But oh my God, get out there and do that sometime. Go visit it. Get your family going a weekend or whatever. I guess it'd be nice when the COVID crap is done, but nothing else. Go for a drive and go check it out. It's really, really cool. Some of my favorites are going up to Duluth and Bayfield, and well, actually everything I mentioned there. They're really, really cool. So anyway, real quick, we're going to take a look at a couple of different systems of water. We got lentic and lotic systems, which you already talked about. Lentic are still bodies of water, and lotic are running bodies of water. And so you could imagine what we'd be doing for the rest of for this entire month here if we were in school. The still body of water, that'd be our Devil's Lake field trip to go try and determine what type of body of water that was. As far as, yes, we know it's lentic, but there's different groupings of it. And then lotic, running bodies of water. Oh my God, people, we live next to one of the most famous ones in the Midwest, of Black Earth Creek. So we take a whole bunch of field trips there. So what I'm going to try and do is see if I can set up a couple of labs that deal with both of those that we could still do related to both lentic and lotic systems. So we already talked about what I need to protect, and we talked about the Chicago, the sanitary canal and the slaughtering and all that kind of stuff. But just real quick, we're just going to go through, starting off here, looking at Lotic systems. Now, I hate to even say this, but one of the most famous Lotic systems out there would have been one. That's actually a picture of the Merced River right behind our hotel in California. That's an example of a Lotic system. Our Black Earth Creek is a Lotic system. But it's fast moving, and there's all kinds of different things that go with it. Well, it doesn't have to be fast moving, but they got characteristics that are unique. The continuous current of varying velocity, water volumes. I mean, it's just obviously the water is moving. A lot of times they can transport material. No thermocline. What that means is that if you go on a lake in the summertime and your feet hit that ice cold part in the lake water, that's called a thermocline. That's a natural separation that occurs. Some laws of physics that go on there that keep the cold layer down below. In a lotic system, doesn't exist because the water's rolling. There's another really good view. I think that's the Mississippi River up just north of La Crosse. God, that's a beautiful flight flying up from La Crosse to Minneapolis. Gorgeous area up in there. Again, another place to go visit. Other things is that we've got two types of lotic systems. We've got a fast lotic system, and you can see the characteristics of the fast system. Now, most of you should recognize that picture, so it should tell you what type of a system that Black Earth Creek is, okay? But the idea is that there's all kinds of different little habitats for critters, these riffles with stony bottoms. All these things make for really, really, really good trout conditions, especially the fact that where does the water come from in the Black Earth Creek? Most of it comes out of the ground, keeping it a moderate, cool temperature, which is great for what? Trout and all the critters that live in it. Gets too warm in the summertime, you get fish die off. And because what does it do with the oxygen in the water? Drives it out. So anyway, and with this decomposition, it gives CO2, you get photosynthesis in the riffle communities, then you get all this life that these trout really need to survive in these conditions. Okay? What they find out, there's a bunch of crud here that we don't have to go through all that, but the idea is that a lot of times the narrower systems are more productive, and a lot of that cuts down on the volume in the middle, because the edges of water areas that you're going to find out, the edges of any limnological structure, the shores, whatever else, is where it's just teeming abundant with life. And so when you have a huge opening in the middle, there's not much shore compared to the volume of the stream. So these these narrower ones are really, really productive. Okay. Gravel and roll bottoms have more stable communities just because you've got a lot more chance for critters to live in there and feed the organisms. Okay. But then you get the slow streams. Now, most classic of all slow stream is one that really wish you guys to get down there and visit. Actually, you've been there. You had a classmate pulled a fish out of a fish tank at one of the places on a slow stream. I'm not saying names, but The most classic example of a slow stream is the Mississippi River. And even though it's a river, it's a stream. Um, the idea is it's slow enough that it's almost pond-like. And it's got low oxygen, high silt load, so you get some really unique critters living in these areas. And it's just incredible the diversity you find on these rivers. Wisconsin River isn't much different. It's very, very similar. Okay. As we said, the best example, Mississippi River. It's extremely diverse just because of its size and its structure. 100 species of fish and clams. Start counting fish. Start counting species of fish and clams. If you knew them, try and get to 100. It's absolutely amazing. I have heard of stories of a guy I knew that was scuba diving. He was checking out the dams down on the Mississippi for structure for the Army, and he's scuba diving down in his helmet, and they're really deep and dark down along the side of the dams, and he's got this helmet light on his helmet, and he said the size of the oh my God, scary critters that came up and smacked into his light. He said he did it one time and never went back down again. Because you're going to have gars and catfish and everything that are the size of the person in the water, alligator snapping turtles that are 200 years old that are as big as a human. Some incredible stuff on that river. Now, there's 3 sections to it. You got the lower below St. Louis, the middle, which is where we're used to when you go down to Prairie du Chien, and then the upper, which is very much like a northern river. So this is the kind right here that we're familiar with. The lower can get very, very, very pond-like, very polluted, and very, very large. The thing is, if you don't know this, Mississippi has been extremely modified. Dredging, wing dams, closing, all these different things because for commerce, when they rank how inexpensive it is to move materials, that they claim that, obviously flying aircraft, extremely expensive. I don't know how many dollars per pound or per ton, I'm sorry. You've got then trucking is the next one that's the most expensive. How many dollars per ton? Rail is really, really cheap. I don't know. It's like, I can't remember the numbers. I don't want to be quoted on it, but the number is very, very cheap. The absolute cheapest of all is shipping material up the Mississippi River. The plant right next to school there, almost every last bit of that corn, or a lot of that corn, heads down in the Mississippi River, down into Butte, into actual old mine shafts in the hills, and it gets stored there, and then it gets elevated out onto barges and sent on the Mississippi. All the fertilizer comes up there, comes up the Mississippi on barges. So it's a huge, huge, huge piece of commerce in the Midwest. These are the dams that what happens is when they constrict the area, the water has to rush through and it actually opens up the middle. That's what they did back before they could actually dredge the river. They just take and dump rocks out, and it would actually dredge the river and make it deeper in the middle so they get the paddle boats through. Here's examples of historically and what they do now as far as moving commerce. I mean, you talk about that in the 1800s. Those are bales of cotton. This is traveling on the Mississippi. That had to be absolutely incredible. All those are hotel rooms. They still do this. You can go to places and still ride that. But I remember going to college in La Crosse and seeing these things here tooling up and down the river. And you look at this, the size of all of this moved by one diesel engine. It's incredible. It would take weeks to move this stuff from New Orleans to Minneapolis. But hey, what's time to hog? It's a really, really efficient way of doing it. And down at the Mississippi River Museum, they had a really nice area in there that described this whole method of moving things in the Mississippi. Really, really, really good for it. But to keep it like that, they have to do dredging. And this kind of cool clip here, you guys can watch how the dredger works. But they got to constantly keep this burrowed out so these ships can get all the way through there. Obviously, not ecologically very good for the environment. I mean, it's wicked for it. You got a lot of benthic organisms that are getting ripped up, and it's really kind of bad for it. But it's part of our commerce, and I don't know what you're going to do at this point besides try and cut down on the commerce and try and slow it down. A couple of things with these. also is that there's islands on these rivers that, well, when the water comes to one end, it actually washes all the silt to the other, and you could use them as an age gradient. Some of these get so large that down in southern areas, they farm the middle of those islands. They're absolutely massive. You think about Louisiana, most of that is a result of all of the silt coming from the Midwest going all the way down there. All I gotta do is watch Bobby Boucher playing his foosball. He lives on one of those things, and down in, I'm pretty sure it was Louisiana. I can't remember. But anyway, I just broke one of my wife's things here. Yeah, and the sloughs are dead-end channels, and down south, that's what they call a bayou. So a slough could go on for miles. That's why people live down in the bayous way down at the end. Yeah, they never find them. Man, it's kind of spooky. So anyway, that's the idea of how big it can get down there. All right, we'll come to lentic systems next, but before we do that, we're going to do a couple of things about the Lotic systems. I want to talk, hopefully get a lab here going on doing some biotic indexing, and then we'll do a little work on the Mississippi River and see what you guys can get out of it. All right, sounds good.